I'm just going to jump right into it. I'm Tim Sheils. I'm a front-end developer at NIH NCATS, and we're part of the IDG KMC, the Knowledge Management Center. And our role is to develop Pharos, which is the front end for the IDG TCRD database, which is a Target Central Resource database, which is a collation of currently 78 different data sources that bring together a wide range of information about targets, ligands, diseases, and sort and rank them based on kind of respective amounts of knowledge available for each. So there's a lot of background information about the IDG, about Pharos, about the TCRD, and most of that can be found in the About section of the main Pharos page. So I'm gonna just jump right into some of our newest updates and some of the improvements that have been made recently with the newest update for Pharos. One of the main functions of Pharos is the ability to browse and filter and search by targets, diseases, or ligands. So upon going to Pharos, you're welcomed with the search page, and you can either start searching for a target or start browsing based on what you're interested in. So we've recently improved our search functionality. Previously, you can search for targets, diseases, drugs, ligands, but you can also search for some of the different filters that we have, like target family, specific gene name, different pathways, and keywords. So if we were to search for CDK, you can pick just a specific target that matches, or ligands associated with a particular target. But if you were to just hit enter, that will bring you to a kind of dashboard page of all of the information in Pharos that matches the text string CDK. So you can view the 291 targets that match CDK, 9 ligands associated with it, different filter types based on targets, whether it's a component, a reactome pathway. We have disease filters based on what disease it's associated with, or filter matches. So that's kind of a more a cleaner way of being able to view what targets or what information is available for a specific text string, and you can use that kind of as a jumping off point. So beyond the search improvements, and it looks a little slow today, we have structure search capabilities that have recently been added. We had it a long time ago and then kind of revamped Pharos and are just now able to bring it back in. So if you were to search for a chemical compound, you can do it by compound name, SMILES, UNI, Chemical ID. You can draw the structure or paste in SMILES. So we're going to go with should have tried to pronounce this first, nimodipine. And what this will do is we have at NCATS a structure, a compound resolver service, where we'll match that name with a variety of other IDs and SMILES that are available to it. So once we have our structure and our query, there's two jumping off points. One is to be able to find similar structures, and you can either do that by similarity or by substructure, or you can find predicted targets using another NCATS service called NCATS Predictor. And what that'll do is that'll give you a list of targets that have predicted activity against that target. And you can kind of see what the predicted activity is, what the nearest activity is for that target, and then what QSAR model was used to generate that prediction. I'm not going to go too deep into the predictions, but there's a bunch of other filters to be able to filter down what activity you want or how applicable it is. So that's kind of a good way to find new targets that may be related to this structure. But if we were going to do similar structures, you can get your list of structures that are similar to it, and we'll probably want to filter that down to 75% similarity, which will filter our list. Again, when we're dealing with the structure, sometimes it takes a little bit longer. Once you do that, there's a newer feature within Pharos where you can do a list analysis on targets. And from this, we can have different visualizations based on the types of filters available. So whether it's a drug or a ligand, we also have upset plots. You can kind of see an overlap if it falls into several categories. You can see what those ligands or what those targets are associated with that. You can also create a heat map based on some of the different activities. So from this list of targets that are 76% similar to our previous compound, you can see a list of all of the different targets that are available, and you can download that list for further analysis. We also added the ability to upload custom lists of ligands. Previously, you could upload target lists. Now you can, using the NCATS Find Resolver, we're able to upload lists of ligands and diseases, which again, I'm not gonna make you wait for it, but this is 500 targets that were pulled out, or 500 ligands that were pulled out from a screen. And we'll go through, we'll see what it resolves to. You can see here's one that didn't match, but it gives you what the initial input was, a lychee, which is an internal identifier that we have in NCATS, if there's data found, and then what to save it as. So once you submit that, again, it'll bring you your list of, it pulled out 469 of those targets, so some of them didn't resolve. And you're able to, again, use this list analysis to visualize the overlap of something like Panther class or what you're interested in. We added a enrichment parameter as well. So if you look at the filters, there's a lot of filters that tend to be overexpressed. So if you calculate the enrichment for it, instead of getting kind of some of the more common filters, this will filter the list down to ones that are a little bit more unique to this list. So, expect it to have this frequency, but in this list, it's observed a lot more often. So that's something where you can click on this filter and then again, filter your list down to these, I believe it was 7 targets or 7 ligands associated with that class. So it's kind of a good way to come with a list of 500 ligands and then filter it down and refine this list based on what you have. And if you're logged in, as you can see, I am up here, it will save this as a custom list that you can use and analyze. So I'll run through one more example real quick based on using a target of interest. So if you have a dark target here, and I'm just gonna chop this up real quick. And so this is a GPCR target that there's not a whole lot known about it. So yeah, we've got our illumination graph, we've got where in the IDG development level it is, and you can find out more about that through the About page. There are some IDG generated resources available for it. But if we go to protein-to-protein interactions, there's 147 targets within StringDB that interact with this protein. So if we use this list as a jumping off point and view diseases that are associated with this list of targets, we're going to end up getting a lot of really common ones, cancers, carcinomas, things like that. So again, if we calculate the enrichment based on that and try to bump up some of these ones that are a little bit more unique to this list, you kind of start to see, for this example, you can see things, here we go. So like depressive disorder, some more mental based diseases as opposed to just your traditional list of cancer. So again, it gives you a little bit, you kind of peel back the layer and can see more commonalities to these lists that you have, and hopefully use that as a springing off point for research. And I'm going to stop there, but you can always leave us feedback through our submission, and in the About page, there's contact information. We're available for tutorials at any time for whoever, and we're always glad to hear feedback. So I'll stop there, and I'll be around if anybody has any questions. Thank you.